Hi guys, it's Marshall from Segway. Today we're going to be taking a look at the Loomo Software Development Kit. To get started, we have to install Android Studio. So if you don't have that installed, go ahead and look up Android Studio, find the main link on developer.android.com, go ahead and download it. Once you have it downloaded, we'll go ahead and open up a basic project. We'll start a basic project on Android Studio. Okay. When you first open Android Studio, you'll be presented with a prompt that looks something like this. Choose your project once you want to start a new project. We'll click a basic activity. That's the basic activity view that we want to start off with. So we'll click Next. I'll name it something like Loomo Locomotion Demo. So we'll be focusing on the Loomo Locomotion API inside of the SDK right now. So we want to make sure that the minimum API level supported is Android 5.1 or API level 22. Loomo runs on Android 5.1.1, so we want to make sure that this is enabled. Then we'll click Finish. Okay, we'll be presented with a new window of our project. The project will build. So once the build is done, it will show us a view of what the application will look like when installed. So we want to navigate over to our Gradle scripts. Gradle is the build service that builds Android applications inside of Android Studio, the development environment. We want to navigate over to our build.gradle, specifically module app. That's the build.gradle file that we want to take a look at. So what we need to first enable Locomotion from Loomo inside of your Android application, the first thing you need to do is to grab the dependency for the Locomotion API. So we'll navigate over to the docs on developer.segway robotics. We'll go to setting up developing environment. Once here, we will find the specific dependency that we need. So we're looking at Locomotion. The Locomotion API all takes place on the base SDK. So this is the only thing that we need to grab. So we'll just grab only this base SDK. So we'll grab that. We'll throw that into our project right here. So I'll specify, and this is a comment. Of course, this is not interpreted code. So say Loomo SDK dependencies. And we'll go ahead and throw our dependency in here. So we're not going to touch the other dependencies. These were generated by us choosing the basic activity project sample from Android Studio. All we're going to do is add this one dependency. Once we do that, we just need to sync. So we'll sync this with the build service. This will rebuild our application, make sure everything is working correctly. Okay, once we're done with that, we can start actually making our application. So as you saw already, the application is going to be very standard. It can work on it. Prior to us adding the Loomo dependency, it could work on any phone or tablet with Android. So it's just got a button right here, a screen that says Hello World. So what we're going to do is we're going to open the Java folder. This is where we can edit the actual code for the application. We're going to ignore the test folders. We don't need to mess with those. We just simply need to navigate to the main activity. So the main activity is where we can define our custom logic for implementing the Loomo SDK. The Loomo SDK is really a set of libraries and packages built on top of Android OS. So it allows us to interact with the services that are running in the background of Android with Loomo running all of those services in the background. First thing we're going to do here is define a base class. So all of the Locomotion APIs operate on the base of Loomo. You can think of the base like the wheels, where the foot pads are, where you put your feet on Loomo. So that's what controls Locomotion on Loomo. So we're going to go ahead and define a base class. This will let us operate on the base. Here it's telling me it can't resolve this this class, so we're going to hit Alt-Enter like it suggests, and that will go ahead and import this class right here. If it didn't import that, then you can do it separately and add this line. Okay, so we've added that class. On create right here, this is when the application is created. What that means is as soon as it launches, the first time it launches while it has no previous state on Loomo, the first time this application is launched on Loomo, this is what happens. It launches on create happens every time the application is quote unquote created, which happens every time, let's say, Loomo restarts, etc. Every time it has lost all context of the application and has to build or has to relaunch the application. So right in here, we want to go ahead and initialize our base class so that we can use it and start making Loomo move. So we'll say mbase, which is our private member variable on the base on this class that we've defined. We'll go ahead and get an instance of that. So the first thing we need to do is from the base class, we're going to grab an instance of a base. So once we do that, we need to go ahead and bind to the service. So all of the central APIs for Loomo are operating as bound services or bind services in the background of Android. It's a key component of the Android operating system and Android development. So it makes it very easy to interact for people who are familiar with Android development, and our documentation online covers sort of how to do this. So I'll show you on the document. If we look up, go ahead and look up Locomotion, which is the API we're going to be targeting today. So locomotion also happens from the head. Today we're just going to focus on the base, which is kind of the key locomotion of Loomo. So we'll see here that we defines how to bind to service and such. So we're just going to be following that guide. So what we need to do is we need to get the application context. Bind service takes two parameters. One is the context of the application. The other is a service bind, bind state listener, sorry. So we'll go ahead and add that. What I did there was tab to complete, and that just added this whole chunk of text. Really, all this is defining a function, a bind state listener. It overrides, the previous functions, unbind and unbind. We don't need to touch this. Once this is here, this is all we need. Okay, so once we have that put in, we have the service bind listener created. What we're going to do is we're going to modify this button. So right here we can see floating action button, fab, equals find view by ID. It finds the ID of the element in the view. We have a listener, so every time, an on-click listener. So what this means is every time it's clicked, this is what happens. So right now in the application, if we were to click this button and it was running on Loomo, it would simply display a small little message that says replace with your own action. So what we're going to do here is, this is where we're going to define our logic for running a simple locomotion demo. To move Loomo, there's a few ways to do it. There's three main modes. There's control mode raw. We're just controlling linear and angular velocities straight off. This is best if you have kind of a complete SLAM system built out and you're trying to just implement how to control Loomo from that standpoint. Control mode navigation, this is adding checkpoints. You can think of this like a coordinate system where you're telling Loomo to move at X position 1, Y position 2 maybe. Control mode follow target, this is for follow me such scenarios. So we'll get to that in a later video. Today we're going to focus on really this one, the navigation mode, and we'll also touch on control mode raw and how to use it. So if we go back to our project here, what we want to do to use a method of controlling Loomo's locomotion is first we need to set it to a control mode. You saw previously we have three control modes. what we're going to do here is we're just going to set it to control mode navigation. So there is a number defined on the base class called control mode navigation. That's the one we're going to select. That will select navigation mode as the control mode. So once we have that done, to move Loomo, we need to make sure that there's no prior odometry. So control mode navigation by default uses an odometry system to move. What this means is it measures Loomo from a certain origin point and measures the directions Loomo has gone and can figure out how to get back to its original point. Using this system, using control mode navigation, it's only accurate within 1/4 of a meter, so 0.25 meters of accuracy. So we'll consider that acceptable for our tests later on. So once we've cleaned the original point, and we make sure that when we click this button, right, when this button is clicked, that Loomo starts at 0. That's the 0 position. Once we do that, we need to set the position and make sure Loomo understands where it is in the world. So what we're going to do is go ahead and grab a pose of Loomo. So we're going to create a pose, and we're going to grab it by saying that we want the pose on our base class, our base object, and we want to get the odometry pose. If we insert a parameter of -1 in here, this will get the latest pose. So that's the one we want. It's the latest pose. So once we've done that, we need to go ahead and set the original point. So we've cleaned the original point, and we found where Loomo is right as we click that button, which is what this line does. In this next line, we need to set the original point. So we're going to set the original point. We're going to give it that pose that we just created. Okay. Now we can get into how to move Loomo. Like I said, control mode navigation by default uses an odometry-based system. So if we look on the documents here, we can see that there's a checkpoint, right? What is a checkpoint? You can think about it like a coordinate system. So we have an X and a Y, and in some cases a theta. We'll just stick to this one real quick. An X and a Y. This simply defines where Loomo is relative to when you click the button, when we started, when we set the original point right here. When we set the original point, that's 0, 0. So when you move Loomo, it goes by meters. So it takes a float, so you can do 1.2 meters, 1.3 meters, 1.4. So X, you can think of positive X, you can think of like Loomo going forward a certain amount of distance or certain amount of spaces in front of him. The Y is of course, the axis counter to going forward and backwards. So you can think of it like left to right of Loomo. So I'll just show you a quick example. We're going to go ahead and add a checkpoint. So if we add a checkpoint, it takes 2 parameters we can see here, an X and a Y. If we put 1F, which is a float of 1, and 0F for our Y, what this says is Loomo will go forward 1 meter. He'll go 1 meter out from his origin point. In 0, he'll stay completely within axis of his left and right axes. So he'll stay completely straight. So this will move Loomo simply 1 meter forward. If we add another checkpoint and say, for instance, 0F in the X, so we don't want Loomo to go any further, and we want Loomo to go 1 meter to the right. Now, the problem with this statement that we just created is a checkpoint can be thought of like a coordinate system. What that means is it's a vector, not necessarily a scalar. What that means is we're not going forward simply 1 meter. We're going forward 1 meter from a position. We started at, we start at 0, 0. So if we're started at 0, 0 and we went to 1, 0, now you can think of like we're at 1, 0. If we try to go forward, if we try to go to 0, 1, that means Loomo will try, will make some sort of turn event to try to go back to um, 0, 1 on the coordinate system. You can think of it like that. So if your intention with a checkpoint is to make Loomo go forward, go right, go left after that, what you need to do is increment along with it. So this will put us at 1, 1, which means Loomo went forward 1 meter and then he went right 1 meter. So that's something to consider when using the checkpoint system. It's a coordinate system. You can think of it like that. So we've written these commands. We have this all written out. So now we can run this on Loomo. So the first thing you're going to want to do is go ahead and make the project. This will, again, build the entire application down to an APK. An APK is what we can use to install on Loomo. So we're going to go ahead and make that. The logs right here, the build log, will show you that it was successful. So the next thing that we're going to do is get Loomo in a state that we can install this application that we've written. Okay, in order to install our application on Loomo, we're going to have to go to Settings. We'll go over here to Settings. And we're going to make sure that we have a Wi-Fi connection. Make sure you have a Wi-Fi connection. Go down to Loomo Developer. Go ahead and toggle that switch. And we will allow developer mode. So in developer mode, we will be able to, of course, install our application that we've created. So we'll wait for that to restart. Okay, when Loomo restarts, you'll be presented with a screen similar to this. It's a normal Android launcher. What we're going to go ahead and do is go into our the main app launcher, and we're going to find our settings application. So we'll find our settings application. In here, we just need to make sure that when we go to System, we go all the way down. We touch the build number a few times. It says now we are developer. What that enables is it gives us this developer options tab that was not there previously. We'll go ahead and click on that, and we need to make sure that our USB debugging is on. If USB debugging is on, then we're good to go. Okay, with USB debugging enabled, and we're in developer mode still, we're going to take our USB-C cable, any sort of USB-C cable capable of transmitting data. We're going to go ahead and plug that into the USB-C port in the back of Loomo's head. Once we do that, we'll plug the other end into our PC, and we'll go back to Android Studio. Okay, now that Loomo is plugged in to our PC, and this device tab has populated with something that says Intel VA50EC, something similar to that, that just represents Loomo as a device is connected. We're going to go ahead and make our project again, make sure that builds correctly. Okay, and now that we have this device selected, we can go ahead and install it to this selected device. So we'll go ahead and hit the play button, and that will, of course, install on this application onto Loomo. Okay, now we'll go over to Loomo to test out our application. Okay, now that we've installed our application onto Loomo, if you've done this straight from Android Studio with the tutorial, you should see that it automatically boots up with the application. So what we'll do is, again, our button right there, we've made that, all the checkpoints are in there. So what we're looking for is Loomo to go forward 1 meter and then left 1 meter. So we'll go ahead and click this. And we'll observe Loomo going forward first. So that was our first command we gave him. And then we told to go left. So he'll go left approximately 1 meter. So again, it's accurate within 0.25 meters. So there could be some discrepancy in there that you notice. So guys, that was our first look at using the Locomotion API inside of the Loomo SDK. So I'll briefly go over another control mode that we can use. So if we want to control the speed at which Loomo moves, for both in linear direction and angular, we need to set the control mode to control mode raw. So we'll go ahead and get control mode raw. So if we set it to there, we can now use two different methods. One is set linear velocity, the other one being angular velocity. So we'll start with linear. Here, this is a method. It takes one parameter, a float, from -3 to 3, anything in between there. This number represents how fast Loomo would be traveling. Negative implying that Loomo can, of course, travel in the reverse direction. And this number represents meters per second, how fast it's moving. So I believe it's limited to about 6 miles an hour, or 3 meters per second in each direction. So if we go ahead and set this number to 1F, this being 1 meter per second, Loomo will, of course, travel forward at that speed. So unlike with control mode navigation, which only allowed us to control kind of the coordinate at which Loomo will move to, this control mode raw allows us to specify what speed Loomo should be traveling at. Now, the interesting thing about controlling the individual speeds at which Loomo moves is that you have to call this continuous. It's not like a checkpoint where you add one checkpoint. Once this is called, if we look at the docs, it has to be called every 700 milliseconds. So if it's not, Loomo will stop. So what that means is we have to run this in a sort of loop, right? And the best thing we want to do if we're going to do that is to create a separate thread and have Loomo's motion controlled separately from the main UI thread, which we're on right now. So I'll go over that in another video of how to use that, how to integrate that with different detection methods, maybe introducing TensorFlow. So this was a brief introduction to using the Locomotion API on Loomo. It's very powerful. You can do a lot of cool things. And I hope you guys enjoyed it. I'll have the source code up. It's going to be in the description down below. And you guys can follow along with that, follow along with the video, and experiment around with using the different capabilities inside of the Locomotion API. Thanks, guys.